let's go ahead and get started. For constructing a one proportion z-test, you should have taken some time to watch the video lesson for 6.3. When constructing a significance test, always remember, like Panic, we have one of those things that helps us kind of remember all of the steps for significance tests. It's called Phantoms. And it's not as nice as Panic because the keywords aren't usually the ones that are highlighted, but it does the job. P is going to stand for define the parameter. H is state the null and alternative hypotheses. A, check assumptions and conditions. N, name the inference method. T, calculate test statistic. O, obtain p-value. M, you're going to make a decision. And S is state your conclusion in context. I know this seems like a lot, but all of these pieces are very, very tiny. And they all are things you've most likely seen. Well, I can say you've done most of this just separately. Now we're putting it all together. So for define the parameter, we are going to do it just like we did for confidence intervals. It's going to be P is equal to the true proportion of whatever the context of your question is. Hypotheses, this is similar to what you did in 6.3. Our null is always going to be equal to, all of the time. Your null should be nothing but equal to. And P naught is going to be the given in your problem. This is usually given to you. It's usually the national average, the CDC does something, you have been told it's this percentage. That is going to be a given value that you're going to claim is the null hypothesis. Now, if it's not given, what we will typically do is we will assume P naught is equal to 0.5, a 50-50 chance of success. Now, for alternative, that's going to be dependent on the question. Either you're interested in the values less than that claim, so you think your population is less, greater, equal to, but slash through it, means I just want to know, is it different? Is it different than what the given proportion is? This is one of those two-tailed tests where we're going to have a shaded region in the lower half and a shaded region in the upper half. Is there a change? Does it match the expected value? All of that language will be very obvious compared to we think this is less or we think this is greater. It will be clear that they want it to be, is it different at all? Now, assumptions and conditions we've done many, many times by this point. You're going to check, is it random? You're going to check the 10% condition. You're going to check success fail. Again, the only change here is that we don't know the true proportion, so we are going to use the null proportion. So whatever number you plug into your null, whatever proportion that is, that's what you use to calculate success fail. And naming the inference method, one proportion z-test. Confidence interval, significance test. Only difference is interval test. First half of it is all the same. For calculating the test statistic, you have done this before. You've calculated z-scores. That is what a test statistic is. You have done it not as formally as we do in a significance test, but you've done it before. So on your formula chart, it's written as test statistic equals statistic minus parameter all over standard deviation. Remember, the formula you generally see is x minus mu over standard deviation. And remember, the mean of proportions is equivalent to the population, which in our case, we're going to use P naught, standard deviation, square root of P, 1 minus P, all over N. P hat is our sample statistic. All of that is stuff we've done before. It's just using the correct symbols for this significance test. Again, all of the symbols are notated right underneath the table just in case you forget what does each one mean. P-value Also something you've done before. We have 3 possibilities for direction, and that's dependent on what your hypotheses are. So if I'm saying P is less than P naught, I'm going to shade everything below my z-score value. Now, in my example, I have it as negative z. It does not have to be a negative number. Sometimes this could be a positive z, and I'm shading everything less than that. I just used a negative one because it's clearer to see shading to the left, but it could be positive. Don't think it has to be negative. If I want P is greater than P naught, I'm shading everything above a z-score. And if I want P is not equal to P naught, I have 2 possibilities. It could be less than or it could be greater than. The nice thing about this particular hypothesis is the z-score is going to be the same value, same number, 1 positive, 1 negative. So really, when you're doing a 2-tailed test, you only have to find 1. And then you will just go in and you will multiply it by 2. My negative z, and oops, wrong thing, sorry. This should be, pick whichever one you want to do. I'm going to do negative infinity to negative z. You could easily just as well find z to positive infinity. Whatever value you get, multiply it by 2. And that's going to give you your p-value. And just a reminder, p-value is going to be the probability of selecting your sample if the null were true. So if I'm living in the world where this proportion is equivalent to some number, this is the chance of me picking the sample that I did. Now, if it's really, really small, that's suspicious. We say, well, there's only a 1% chance of this happening. How could it have happened? There's only a 0.05% chance of it happening. That makes me suspicious. That's why we use p-values to determine if we are going to either reject or fail to reject the null. So that's when we get down to the make a decision part. So if the p-value is less than alpha, and in most cases, they're not going to change alpha. They're not going to state anything. If nothing has been said, we assume alpha is 0.05. Sometimes they'll say, given alpha is 0.1 or 0.01. But if they don't say anything, go with 0.05. And then if the p-value is greater than alpha, we fail to reject the null. And yes, this is one of those things where language is really important. We don't necessarily say we accept the null. Because remember, all of these significance tests, all of these confidence intervals are based on one sample. And there's tons of sampling variation. So based on our one sample, we just don't have enough evidence to disprove the null, is what we're saying. And this language, reject and fail to reject, is what they will be looking for on the AP exam. That is what they want to see. Now, easiest way and most comical way to remember what you should do when you are making a decision is, if the p-value is low, you reject the hoe, as you should in all things in life. So that is the one thing that students will remember from statistics for the rest of their lives. They'll be like, yeah, there was something about rejecting hoes. Don't really remember why, but that's that is what the easiest way. If your p-value is low, reject the hoe. Now, see, Ben's going to always know. He's always going to remember. Now, once you've made your decision, you have to write it in context. So I have organized this online. It's probably easier to see because you have colored notes, hopefully. In person, it's probably black and white. It is black and white. So I color coordinated it. All the red words should go together. That's all one selection. We're going to select less, reject, and is. All of the green words are going together. Greater, fail to reject is not. This is the format we will use for our conclusions for significance tests until the end of time. Since our p-value of will fill in the blank, generally I report my alpha in my conclusion. We either are rejecting or failing to reject the null hypothesis. There is or is not convincing evidence that the alternative hypothesis is true. Now, before we get into actually performing one of these significance tests, I do want you to take note of the calculator steps, just so that you have them written down somewhere or typed, because I will show you how to do it by hand, and then we will verify our answer in the calculator, just so that you get practice with both. And again, this is one of those topics where AP exam will let you do this in your calculator. They will let you use it. It's just, it's going to take place of the portion that I'll kind of point out in phantoms. It'll take place of T and O. And this is also going to be found within that stat tests menu. It's going to be option number 5. It's going to ask you, what is the null proportion first? Then it'll say, how many successes do you have? How many people did you sample from total? And then the prop part is going to be your hypothesis, your alternative hypothesis. It's going to ask for direction. Do I want greater than? Do I want less than? Do I want not equal to? All of that gets plugged in. This is a part where you want to be careful, because a lot of students accidentally hit the wrong button for the direction. Calculate, then it'll replace T and O once we get to those steps. Everything else in phantoms still has to be done. You still have to define your parameter, state your hypotheses, check your assumptions, name the test. Then you can put in your calculator work, conclude. Do you have a question, Gwen?
So on the obtain the p-value for the last one, or on the thing, this is the lower is negative c and the upper is c. You also do that one with the negative infinity and negative c.
It may be wrong on your paper. What does it say on your paper? Negative z to negative z to positive z? It should say negative infinity to negative z, or it could be z to positive infinity.
So you just have to multiply it by 2.
Yes, we don't want the area between those two values. We want the area outside of those two values. I know I whited it out for a reason and then just didn't make any changes. Okie doke, let's go ahead and get started. Example 1. First thing I have, according to the U.S. Census Bureau, the proportion of students in high school who have a part-time job is 0.25. An administrator at a local high school suspects that the proportion of students at her school who have a part-time job is less than the national figure. The administrator selects a random sample of 200 students and finds that 39 of them have a part-time job. I always get the question, how do I know I'm supposed to be doing a significance test? Generally, the language they use on the AP exam is their convincing evidence. That is going to be your signal to go and do a significance test. Sometimes they're very kind and they'll outright say, do a significance test. Often, this is how it will appear. That the proportion of students at the administrator school who have a part-time job is less than the national figure. Well, our P, our parameter, we're trying to see the true proportion of this particular admin students with part-time jobs. Be careful. Don't state something that's all high school students. That's not what we're interested in. We're interested in the population at this particular admin's school. Now, the national average is 0.25. That is the given proportion. So that is going to be my null hypothesis. P is equal to 0.25. And the administrator thinks that her school is less than that. So my alternative is P is less than 0.25. Now, the reason why it's so important that we define P is because you're telling them words within your null and your alternative, so that you don't have to write out fully thought out hypotheses every single time. You're giving them what P means so they know what to plug into the null and the alternative. Now, A, you should be very familiar with at this point because we've done it a million times. First thing we do is check, is it random? We have random sample stated. Took a random sample of 200 students. Second thing would be our 10% condition. We can assume that there's at least 2,000 students in the population because she sampled 200. Take 200, multiply it by 10 to give us 2,000. Last condition would be success fail. And remember that we're going to use the null proportion to plug in to the P part. So N is 200, P is 0.25. I multiply those two together. I get 50 successes. I do the opposite, so 0.75. I get 150 fails. So that's both greater than 10. So I have approximately normal. All three conditions are met, so I shouldn't run into any problems in my conclusion. One small note, if one of these tests happen to fail and you are on the AP exam, the expectation is that you just notate that it's failed, proceed with caution in your conclusion. You can say something along the lines of, the success fail condition was not met, therefore my results may not be accurate. Generally, I will say they're not going to throw that at you, but just in case. Name of the test, one prop, one proportion, z-test. Very, very important, especially if you go the calculator route, that you name the test. If you're doing it by hand, oftentimes they will give you credit for showing your work by writing down your formula for the z-score, writing down your direction, shading a graph. They will say, okay, they know what they're doing. They'll give you the credit. If you plug this into your calculator and you don't have the method written down, they won't give you anything. So it's very, very important that you do this. Now, first we're going to do it by hand. Test statistic. I'm going to calculate a z-score. First, I'm just going to remind you of what the formula is. You do not have to write the formula down every single time. Oftentimes, we advise that you do not because you will use the wrong symbols, and AP does not like that. College Board does not like the use of the wrong symbols for problems. I know what P naught is, 0.25. I know what N is, 200. P hat, I will have to calculate. That's my sample statistic. So I'm going to take her survey of 200 students. 39 of them have a part-time job. So my P hat is 39 over 200, which is 0.195. And then from here, I'm just plugging in what I know. I know that my P hat is 0.195, P naught is 0.25, and my sample size is 200. Just plugging in my values. Now, calculator work from here, I always advise actually entering a fraction bar into your calculator. Alpha y equals number one. Best way to organize problems like this, especially when you have a fraction within a fraction. Parentheses, opening and closing them can be kind of tricky, especially when you're getting past that first line window screen. Always suggest doing it with fractions. And this value is approximately negative 1.7963. Typically, I will always round things to 4 decimal places. I do want you to be careful on the MyLab stuff. I think they normally have you round to 3. That's kind of gotten some students frustrated because they put in 4 and it's like wrong. It's very frustrating, but 3 is typically MyLab's preference. So now that I know what my z-score is, if I'm doing this by hand, I will always sketch a picture. I will always draw a normal curve, and I will draw my z-score on it and identify what area am I interested in. Well, the admin thinks that it's less than that z-score. So it's every possible p-hat to the left of my z-score. And from here, it's just normal CDF. Remember, if you are doing things by hand, you do have to write down and report your normal CDF inputs. My lower bound will be negative infinity. My upper bound will be negative 1.7963. Mean of 0, standard deviation of 1, because we are working with z-scores. If you forgot calculator steps for this, second, vars, this should be option number 2. Remember, for negative infinity, we actually put in negative 1e99. Once I plug all of this into my calculator, I get 0.0362. This is going to be my p-value. This is the value if my null were true. If the population at this admin school of students with part-time jobs was 25%, then the chance of her picking the sample that she did, those 39 out of 200 students, the chance of that happening is 3.62%. Really, really small. Now, anytime we dip below 5%, that's when things get suspicious. So I have 0.0362 is less than 0.05. Ben, when the p-value is low, what do we do? Ben?
Oh, you said my name?
Yeah. What do we do? If the p-value is low, we
Forget the hub.
we don't forget. We don't forget. What do we do?
Reject the hub.
We reject the hoe. If the p-value is low, we reject the hoe. Put that in your brain. Say it to yourself. He's trying to make everyone remember it, and he forgot it already. If the p-value is low, reject the hoe. This is one step that you don't necessarily have to write down formally, because in your conclusion, you will state it. I just put it in here for the sake of notes, so you guys don't ask me later, why did we do this? Oh, I just keep pressing extend. How far did we go? Here we go. In your conclusion, you will say reject. So you don't have to write down the M part, but in your mind, you need to make a decision. Either you are rejecting or you are failing to reject. P-value is low, reject the hoe. And again, all of those red words, those first words in our model, go together.
What is that little thing before the 0.05?
Alpha,
Why is it?
because that's how alpha looks. How alpha's, we've looked at alpha like 20 times. It looks weird today.
It looks weird today.
Yeah, looks weird after Thanksgiving break. So since it is less than our alpha, we reject the null hypothesis. We have convincing evidence that the proportion is different at this administrator's school. Nice one, Ashir. Very nice. So while you are writing this down, I'm going to kind of start walking you through how you could do this in your calculator. Remember, Everything else has to be there. The calculator steps will replace calculate the test statistic and obtain the p-value. So I'm going to kind of half screen this, hopefully. Let's see. Maybe not. Maybe we'll just full screen it for now. There we go. I will come back to the conclusion. So you're going to go to stat. You're going to go over to tests. And you're going to go down to number 5, one prop z-test. Do not get tempted by number 1. That's not the one you want. You want number 5. So then I'm going to hit enter. It's going to ask me for a couple of things. First, what was P naught? Well, in our case, it was 0.25. What was the number of successes? 39. Oops, 39. What was the sample size? 200. And then what was your alternative hypothesis? Be careful because this P naught is 0.25 and we wanted everything less than that. So the option I'm picking is number 2. This is where students often forget. Just make sure you plug in 0.25 in your head and see which one matches your alternative hypothesis. You don't have to do anything with the color. We are going to go straight down to calculate. And if you notice, z is equal to negative 1.7963. And the p-value is 0.0362, which is exactly what we got when we did it by hand. Now, similar to what we did with confidence intervals, you will have to write everything down from that output screen. Write down the z value, write down the p value, write down p hat, write down n. Anything that comes from your calculator, write it down. You don't have to write down your input. You don't have to say p naught is this, x is this, n is this. You have to say what it gives back to you in order to get credit on the AP exam. So I'm going to give you a minute or two to finish writing your conclusion, and then we will move on to our final example. Yes, Gwen?
So, like, what are the tells that, like, show you, or that let you know that this is a significance test?
That is their convincing evidence. In the case where they want you to do a confidence interval, that language is more straightforward. They will say construct a 95% confidence interval. And those are really your only 2 options right now. Either you're doing confidence interval or you're doing a hypothesis test. So if it doesn't say interval, run with a significance test. Okay, let's go ahead and look at our last example. We have, according to the CDC, 68% of high school students have never smoked a cigarette. Ava wonders if this national figure holds true at RHS. For an AP Stats project, Ava takes an SRS of 150 students from her school. She gets responses from all 150, which is impressive. And 90 say that they have never smoked a cigarette. Is there convincing evidence that the CDC's claim does not hold true at Ava's school? Well, first we have to define what P is. P is going to be the true proportion of RHS students who have never smoked a cigarette, because that's what she's interested in. What's the real number at RHS? That's what we're trying to figure out. And we're comparing this to the CDC's claim of 68%. So what we're going to do is we're going to set our null equal to the CDC's claim. Now, the language of Ava's question is she wants to know if this national figure holds true at RHS. She doesn't say, is it greater at RHS? Is it less at RHS? She just wants to know, is it 68% at RHS or is it not? So in those cases, we have our alternative be not equal to. If you don't see less than, greater than, more than, less people, or any of those language terms that make you do a less than sign or greater than sign, it's always going to be not equal to. They will specifically say they think the value is lower, they think the value is higher. Those comparative words that tell you to use an inequality sign. In this case, it doesn't say any of that. She just wants to know, is it true? So not equal to. Assumptions and conditions are satisfied. Let's do first, is it random? Second, assume at least 1,500 students in the population. Seems fair. And my success fail. I have at least 102 successes and 48 fails. So that satisfies the greater than or equal to 10, meaning it's approximately normal. And the name of the test, one prop Z test, one proportion Z test. One thing I do like to cover and let you know, sometimes you'll come across a question that will say, assume all assumptions and conditions are satisfied. Don't doubt them, just go with it. In the place of writing down all the assumptions and conditions, just say assumptions have been verified or stated that assumptions are verified. That's all you have to do. Keep moving on. Because a lot of the time they throw those in there just to save you some time. So you don't have to check conditions for every problem. If it doesn't say something like that, then yes, you should go through and do random 10% success fail. But don't be like, I don't know, maybe they're lying, and check them anyway, which is fine. It's just going to take a little more time than they probably intended. So I have my one proportion Z test. I'm going to calculate my test statistic. Now again, I'm just plugging into that Z-score formula. I already know P naught. I already know N. The only thing that I have missing so far is Ava's P hat. She took a sample of 150. 90 of them said they have never smoked a cigarette. So her P hat is 0.6. I will take my P naught, which is 0.68, my P hat, which is 0.6, my N of 150, and I will plug all of that into my Z-score formula. And I will approximate my Z-score to be negative 2.1004. Now, don't forget that we wrote an alternative hypothesis where it's not equal to. So I don't necessarily have one direction in which I am shading. I have two, but the nice thing about a two-tailed test is there's symmetry. The Z-score on the upper end is the same number, just positive. So negative 2.1004 and positive 2.1004. So again, if I'm doing something by hand, I always like to sketch a picture just so that I can kind of visualize what am I interested in? What's the area that I want? And I want the two tails of a normal curve with Z-scores of 2.1004. The nice thing about this, you only have to find one. If you can find one of the areas, you just multiply it by 2. So you can either pick going from negative infinity to negative 2.1004, or you could pick 2.1004 to positive infinity. Either one, they're going to give you the same number. So I believe I picked the negative option. I went from negative infinity to negative 2.1004 with a mean of 0 and a standard deviation of 1. And I got a p-value of 0.0178. If I were to go in my calculator and instead of negative infinity, I wrote 2.1004 to infinity, I'd get the same number. So because there is symmetry, because it's the same Z-score on either end, it's the same p-value. So my final answer will be 0.0178 times 2. because the 0.0178 is just this area. And then here's another 0.0178. So I have to add them together or multiply them by 2, however you want to think about it. And my p-value for this problem is 0.0356. Now, before we get to the make a decision phase, I'm going to show you how to do this in your calculator, just because I want to talk about something really quickly. I'm going to go to stat. I'm going to go over to tests. Oops. Back down to number 5. Again, do not get tempted by number 1. Go down to number 5. My P naught is 0.68. My number of successes was 90. Sample size was 150. This time I want not equal to, and this time I'm going to calculate. I want you to notice we get the same z-score, negative 2.1004. However, the p-value has already been multiplied. Do not make the mistake of going in, running the test, and then multiplying it by 2. Your calculator takes care of that. There's always something in the back of your mind that's like there's something that needs to be multiplied by 2. Not when you're doing it in the calculator. Calculator takes care of that. Do not worry about it. Just put down the p-value that is reported. So my p-value is low. What do I do when my p-value is low? Reject that hoe. And then you conclude, since our p-value of 0.0356 is less than my alpha of 0.05, we are going to reject the null hypothesis. Almost knocked my whole computer down. There is convincing evidence that the proportion of RHS students who never smoked a cigarette is different than the CDC's claim.